now we want to talk about the different kinds of structures that are formed by stresses. And the first structure that you need to be familiar with is parallel structures. So for example, in the ocean, calcium carbonate precipitates down, and it's going to make layer after layer of limestone, and it's going to make parallel beds. So now this is the sideways view, and you can obviously see that these are parallel beds. Okay, but what would it look like from the top down view? So if you're in an airplane looking down on these beds, what would they look like? So let's say that erosion occurs, and so erosion comes along, and now you've got this mountain like this. So we can now erase all of this stuff over here and erase this stuff over here. Okay, what are you going to see from the top down view? You're going to see a series of circles. So you're going to see a circle here, and then another circle here, and a circle here. So it's going to be circles within circles. So this is the sideways view, and then the up and down view is going to be a circle, and then here is another circle that goes around it, and then here is yet another circle that goes around that. So that's what these horizontal beds would look like from the air, circles within circles. Now what about if you had a horizontal bed like this, and now let's say that we tilt it? What's it going to look like? So from the sideways view, it's pretty easy to see that you've got your tilted beds. But what's it going to look like from the top-down view? Well, this time it's going to make a series of stripes. So here is the surface of the Earth, and then wherever this thing makes contact with the surface, it's going to make a stripe. So you got a stripe here, and a stripe here, and a stripe here. So that from the top-down view, horizontal beds, when they're dipping, are going to make a series of stripes. Now we can describe the orientation of those stripes by using the words strike and dip. So here is the surface view, and these rocks are going to be going in this direction, so that's going to be the strike. Okay, then this though, this angle that it makes as it goes back into the earth, that's going to be the dip. So you can measure the strike of a horizontal bed and then the dip of a horizontal bed. All right, now what happens if rocks break? So this is going to be brittle structures, and now let's first assume that the rock breaks but there's no movement. So it's not like the rock broke and then it did that. So the rock breaks, there's a crack in the rock, but there's no movement on either side of the crack. That's going to be called a joint. Sometimes that joint can get filled with minerals. And so things like gold and silver can fill in those cracks, and then you have a vein of ore. All right, you should remember this from when we talked about earthquakes. So one thing that can happen when a rock breaks is that one side can slide down with respect to the other side. So that's going to be a normal fault. You should be able to identify a picture of a normal fault or be able to draw a picture of a normal fault. A special example of a normal fault is going to be a Horst and Graben. So it's going to be repeated normal faults. So for example, here's what it used to look like was like this. So here's your horizontal beds, and then let's say that over here there was some kind of an earthquake, and this part slid down like that. And then over here there's going to be another crack, and so these layers are going to slip down with respect to these two layers over here. So it's a normal fault, and so The place where it slid down, that's going to be the graben. The place where it's higher is going to be the horst. Grabens tend to make basins, and the horsts tend to make mountains on either side of it. And then you can also see that sometimes these horsts and grabens can have different angles associated with them. All right, you can also have a case where a rock breaks, but instead of it sliding down like this, it's thrust up on top of it. So it's thrust up, so that's going to be a reverse fault. Sometimes it's thrust up so much, sometimes it's going to be thrust up so much that it lands on top of it. So that's going to be a thrust fault when that occurs. So a thrust fault is a very severe reverse fault. What are the forces associated with this? So you need to know that in the case of the normal fault, it's tension. So when the rocks are being pulled apart like this, then it tends to slide down. On the other hand, with this one, that's compression. So where the rocks are being pushed together like this, then that's going to make it want to go up like that. Okay, then you could also have strike slip faults. So in a strike slip fault, they slide past each other, and so that's going to be caused by shear stresses. And then the oblique slip is where you can have it sliding sideways and at the same time sliding up and down. So when you put those two motions together, that's going to be called an oblique slip. Okay, what are some other structures that are associated with this? So one is going to be fault breccia. So that means that in the rocks in between the two rocks over here that are sliding past each other, the rocks in between can get pulverized. So that's going to be fault breccia. Very angular pieces of rock. Okay, slick and slides are going to be scratches. So when one rock rubs up against another rock, it can scratch it. And so those are striations on the rock created when rocks slide past each other. Okay, let's take a break, and when we come back, we're going to talk about what can happen this time when rocks bend.